learning model that you got to. So I'll continue from there. But before I continue, I want to hear everybody's voice. I don't want to be the only one talking. Hope you can hear me clearly. Hello everyone, can you hear me?
Yeah, I can hear you, sir.
Sorry, I cannot hear
Yeah, I can
you,
hear you.
Emmanuel. It seems you are talking, but I cannot hear you.
I said I can hear you. Can you hear me now?
Hey, your voice is slow. Okay. So I'll be sharing my screen now. I'll be sharing my screen now. Okay, so this is the notebook we are currently working on, and it's like the sample exam for the data scientist associates. And it's like the similar things you are going to be meeting in your main examination. So let me run it. Okay. Okay. So Mr. John said you got to, sorry, tax, what did you stop last week? Sorry, tax, what did you stop at last week? Please, can you hear me? I cannot hear anyone's voice. Sorry, can you hear me? Tax 2. Okay. You completed tax 2, right? You completed task 2, right? Ah, why is everybody muted? Okay. But wait, oh. But one thing is, I cannot continue with this class if everybody remains muted. Please, I want this class to be interactive. Everyone should like unmute and speak, please.
So I didn't.
Sorry, can you hear me?
Yeah, I can hear you.
Okay. Yeah, you were saying.
I
Good
said
evening, sir. I'm here.
Okay.
Sorry, were you asking a question at
Okay.
some point? I was not paying attention. I'm sorry.
Yeah, I was asking where you stopped last week so I can continue from there.
Okay. We stopped at. We were trying to train the model. We were trying to train. We were trying the baseline model. So he imported the necessary
Okay.
libraries, linear regression, the cross validation, then they train test splits. Yeah, I think yeah. So he was trying to train it as a. I mean, he was trying to build the
Okay. Okay.
baseline model. Yes.
Okay. So with that, I'll be continuing from task 3 then. Hope that's fine. I think yeah, you started, so I can just start task 3 and then task 4. Okay. So actually in data science, what we usually do is that anytime you have a problem like this, the first point, like, and you have to build a model for prediction purposes. The first step we usually take is that you are going to build a normal generic baseline model, like just a very simple model. So after you build that very simple model, and then you start to fine tune until you get your final model. It's always better to start from a very simple and easy model, and then later you now start fine tuning until you now finally get your best model. So, and in this task, we are the what we are trying to predict is spend, and spend is like a continuous data, so that's a regression task. Classification is if you want to, like, if your target variable is discrete, that means your task is a classification task. But if your target variable is continuous, it means that your task is regression. For example, if I want to predict which class someone is in, a secondary student, I want to predict the class the person is. We only have 6 type of classes: JSS1 to 3, SS1 to 3. That's discrete. So that type of tax, we call it classification tax. But anytime I want to like predict something that is continuous, like money, age, height, things like that. So the type of tax we are working with in that case is regression. And the simplest type of regression model we have is the linear regression. And linear regression is just like, for example, the line of best fit that we used to do when we're in secondary school mathematics, that will have lines, and then we calculate the line of best fit. That's exactly what a linear regression does. It will look for the line of best fit for our data, and that line is what it will be using to predict any input value we give it. So that's what we will be starting with. And let me read the task. Fit a baseline model to predict the spend over the year for each customer, and fit your model using the data contained in train.csv. So use test.csv to predict new values based on your model. You must return a data frame named base results that includes customer ID and spend. The spend column must be your predicted values. So in this information, there are like a lot of things we need to like consider. We need to take notes. The first thing is that fit your model using the data contained in train.csv. It means that all the data cleaning that we did earlier, all those clean data that we did, we are actually not using the cleaned data. There's a different type of CSV we are using for this classification task. And then they said use test.csv to predict the new values based on your model. So in this work now, in this sample exam, there's test.csv. But in the main exam, if I remember clearly, you are going to be having validation.csv. So be careful of the name. And they said we should return a data frame named base_results. That should be the name of the data frame. And it should have just 2 columns: the customer ID and the spend. So here now we are going to import the necessary libraries that we need to use. This train test split is to split our data into training sets and test sets. This cross validation score is for the second model actually, when we are using cross validation, k-fold, and then randomized search. All these 3, we are using it to like fine tune our model in the second one we'll be building. So yeah, the 2 type of model we'll be working with is linear regression, and then ridge model. And our metrics to calculate the mean squared error. If I remember clearly, in the main exam, they will ask you that the RMS, root mean squared error, from the 2 models should be less than 30,000. So we need to first check our model before we submit, because the final metrics will be based on, the final evaluation will be based on a data set that is not available for you during the exam. So we need to first, the data set they give us, we need to first split it into 2. So we train it on one, evaluate it on the other. to be sure that the RMSE is less than 30,000. So when we submit, it will now be evaluated on the Indian data set that was not provided. So it has to be less than 30,000 on that Indian data set for you to pass. So the first thing we have to do is to import our train and test sets. But before I continue, can you all hear me? Because I've been the only one speaking since. So sorry, can you all hear me? Hello everyone, can you hear me?
Yes, sir. We can hear you.
Yes, sir. We can hear you, sir.
Okay. So great. So let me continue from there. So the first thing we need to do is to import our files, the train set and the test sets, the train data set and the test data set. So I think it's still loading. So I think I'm not logged in yet. That's why I'm not able to like run the notebook. Let me quickly log in. So hey. I think to save our time, I think I can just I think I'm just going to work with it offline so that to save our time because of the network, it's taking time to load. Ah, about in okay. Uh, eh, uh, eh. Sorry, my network is taking time. Uh, okay, so it's still loading. Hopefully it loads now, and I will not get error. Okay. 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 Sorry, can you all see my screen? Sorry, can you all see my screen? I'll be using this offline one.
I
So
don't
you
think
said
I don't think your screen is visible.
Yes, screen is not visible.
my screen is not visible.
It's not
Okay, what
visible. It's
about
not
now?
visible.
Okay,
It's
thank
still
you.
not visible.
So I'll be working with it offline. The online one is taking time, like train and test sets. Here's few values in our training. So if we check our training data sets, we have the customer ID, the spend, the first month, the amount the customer spent in their first month, items in first month, the number of items the customer purchased in the first month, the region of the customer, the loyalty years, like for how many years have they been on the loyalty program, and then the month they joined, and promotion. I've forgotten what this promotion is. Let me quickly check. Did the customer join the loyalty program as part of a promotion or not? Yes. So those are the variables we have. And if you come to the test set here, so we see that we have everything apart from the target, that's the spend. So we have everything here apart from the spend. So the first thing we need to do is this transform data. We need to like for every machine learning project, the final data set you have to send to your model to train your model on must only contain numbers. Please let's take notes. The final data set that you will send to your model should only contain numbers, should not contain any string or any letter in any everywhere. Anywhere you have data that are not like numbers, you must find a way to convert them to numbers. Even ChatGPT that like takes in prompts and then return it back in human language, it's the model itself works on numbers. There are like some ways to convert everything you typed to some kind of numbers. and then everything is generating, we first generated in form of numbers and then interpreted to English. So one thing we should always take note, machine learning model is only trained on a data set containing only numbers. Please, let's take note. And here, the columns we have that are not numbers are the region, the loyalty years, 5 to 10 is categorical. The region is also categorical. The joining month is also categorical. And then the promotion, whether yes or no, that's also categorical. So for this promotion, it's very easy. For binary values like this, yes, just convert yes to 1, convert no to 0. But there's a better way to go about it. There's a better way to like work with all these categorical values to convert them to numbers. The way we usually do it is we use pd.getDummies. So we are going to be getting dummies for each of those columns that are not numbers. But I want to ask something. Everybody, can you hear me? Sorry, can you hear me?
Yes, we can, Mr. Usman.
Okay, so now
I'm
if
still not
you
seeing
have
your
a
screen, sir.
column,
Are you still sharing?
and are you not seeing my screen?
No, we
I'm not seeing
them
your screen.
them indicated that they cannot see your screen, so I don't know. Your screen is not visible.
Okay, so let me do something. Let me stop and then reshare my screen. Oh, sorry, I did not share screen. Sorry, let me share it. Apologies. I think my screen sharing stopped and I did not know. Sorry, can you see my screen now?
Yes, we can see.
Yes, go ahead, you can.
Okay, yeah, great. Okay, now I want to ask. So, for example, if we have a column that contains dates, dates like 20th of August 2025, things like that. Or what's today's date? 22nd of November 2025. So, how do we go about that date? We have to convert or everything we have, we must convert it to numbers in some way before we feed it to before we train our machine learning model on it. So how do we convert it to numbers? How do you think we should go about converting it to numbers?
You can use this pandas get dummies one hot encoding.
No, if we use one not encoding for dates, it means we are going to be having a lot of dates. Dates can span like 5 years, can span like multiple years.
Okay,
We know
we
that
we
for
can
each
convert
specific
it
date.
to. Can we do this? We can convert it to date time. Yeah, we will not extract. We will not use the DT to extract the month, the year, the part of this thing, the date, so that we can work
So
with it.
that's exactly okay. Yeah, that's exactly what I want to explain. Because anytime you have a date, you extract the day as a column, the month number, like month January to December 1 to 12, and also the year. So that one, with that, we've gotten 3 columns that are now numbers for each date. Yes, so that's what I want to explain. So for all these ones now that are not categorical, like for region, loyalty years, and then joining month, and then promotion, those are not the ones we will now use pd.getDummies for. So these are the ones we will use pd.getDummies for. And so I did an explanation, although this data set does not contain any dates. So I just did an explanation here. If there is a dates column, extract the year, month, and day separately. And once we've extracted the day, the month, and the year, remember to drop the dates, because it will be like too much. It will be unnecessary information. And once we've extracted the part, the real date is now unnecessary. So you need to like drop it. And then for the region, for each of those data set columns that are now categorical, we will now start getting dummies for them. You say pd.get_dummies df into region, comma drop first. We usually use this drop first for a reason, to remove correlation later, like to remove correlation within our columns. So here too, you do it for each of them, 1, 2, 3, 4 that I have here. So I have pd.get dummies for each of them. Now, these ones now are not training data set, like they are data there are data frames on their own. So I need to join it with the initial training data sets, and then remove all those columns that I've gotten dummies for. So the first is I'll join the region, the ones that have the dummies for region, loyalty years, joining months, and then remove the main columns that I've gotten the dummies for. So, and then I define this here as a function, because this function we use here to get dummies for the training set, we must replicate the exact same procedure for our test sets. So that's the reason why I did not just use it as a code. I put it in a form, in a function, because I must replicate the exact same procedure for my test sets, so that my answers are going to be consistent. And one thing you should always take note, when I was doing the practical exam, I failed the first practical exam for just one mistake that I did not even like think about, like for just the slightest mistake. And what was the mistake? This function, I called it clean underscore data. But can anybody tell me why clean underscore data is not okay? It's not okay to name my function clean underscore data. Can anybody remember? I think I explained it one time. Somebody made the exact same mistake on the Discord channel. I was correcting the person. No, not exact same mistake, similar
I
mistake.
think you say the clean underscore data will like refer back to the name of the data set.
I Sorry, can you come again? Can you?
Like what I can remember, you were saying that if we use clean data as the function name,
Yes,
that the data
yes.
set itself bears the name clean data. I think something like that. That is not
Okay,
advisable to do that.
okay. So what happened is that for each tax, you have 5 tax. For each of the tax, there is a final variable that you are creating. And that final variables, it is only those final variables that will be evaluated. So once you submit your exam, DataCamp will run everything to generate all the variables. And then it will now search for those 5 variables and then start marking them. And if you go back to tax, is it tax 2? No, it should be tax 1. Yeah, it should be this tax. Look at what they said. Your output should be a data frame named clean underscore data. It means that for this tax, the only thing data camp want to mark is this variable. It will just check whether you generated it correctly as it is expecting. Now, I've defined clean underscore data for tax 1 now. This is clean underscore data. Is a data frame. Now, if I go to this tax here, tax 3, and then I now name my function clean underscore data, it has overwritten that data frame, the final answer that want to be marked in tax 1. It has overwritten it. So once data camp has run my code successfully, it will now be looking for clean underscore data. It will no more see it as a data frame. It will see it as a function. So it's going to mark it wrong because I've overwritten it. Do you get what I'm explaining? Do you get this class is not interactive. Oh, please let's be interactive. Do you get the point?
Yes,
Yes,
so yes,
yes.
we get it too.
Okay. So actually, in my first submission, I named this function clean underscore data. So when I submitted, all the tags was correct, apart from that tax that requires clean underscore data. So when I was now checking it, I checked the output is requesting clean underscore data, and then I was not seeing that it is a function. Clean underscore data is a function something something. So when I now check here and I saw that, oh, I named the clean underscore data, I was like, no, 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 I deserve beating. No, I deserve it. I know. So don't make the same mistake. Don't make the same mistake. So I'll call it transform underscore data. And then now, if you check the initial data set, customer ID, and then this is the thing spent first month, items in first month. Now you see this region now, all the possible values we can have, we've now expanded them into columns. It will only be one when the region is Asia. It will be one when the region is Europe. The Middle East slash Africa column will be one when the region is the Middle East slash Africa. And it will be zero when it is none of this, because there are 4 regions. We've dropped Americas because once everything here is zero, automatically we know that it is what? Americas. So there's no need to be like adding unnecessary column. So let me look at the first 10 values. So I'm having two. I'm looking for where I'm having false. So in this case now, look at the sixth person. False. It means that this person is what? The region of this person is what? America. So the reason why we usually drop that first is that no column here, no column here. We should not be able to predict the value in any column from combination of any other value, any other columns. And from these 3 columns, if here is false, automatically Americas is what? True. So we need to drop one of them once we get the dummies. Same thing goes for the loyalty years. Same thing goes for the months. You see that 1 month is missing. The reason is that once we know like every other month and every other month is false, automatically that month is what? True. And then if any of the other months is true, that means that month is what? False. So we can predict that month from every other month. So we need to remove 1 month, and we usually remove the first one. So that's why I usually have this drop underscore first in our get dummies method. So yeah, this is now the data set I have now. You see all these false and true will be interpreted as 1 and 0 finally for the model. So we've already gotten everything as numbers now. So the next thing now is for my training set. So I need to get my my variables and the target column. So these are like my I don't know what we used to call it though. The one I want to use to predict. So I need to drop the spent column, which is the target column for my X, and my Y will now be the target column. That's the spent. And then I need to split. I'm using 30% for my test set here. It means that in my data set, if I have 10 values, I'll be training my model with 7 records and then testing it on the remaining 3 records. So that's why I have 0.3, 30% as my test set. So here, let me split into X and Y. So I've gotten my X test, Y train, Y test. So yeah, now this is like the baseline model that I have, a normal linear regression. I'm not fine-tuning anything. You can see that in this bracket, I'm not putting alpha is equals to anything. I'm not putting anything, just the model, the way it is, without any fine-tuning. So that's what I'm using as my base model. And in this place, linear regression dot fit, I'm training it on my X train and Y train. And then I'll get the prediction. I'll get my Y predict on my X test. My test X test, I'll get the prediction on my S test. So yeah, the mean squared error metric that I imported earlier. So that's what I'm using here to check my mean squared error, to check whether I still need to like fine tune more. Because in the exam, they will ask you that your RMSE should be less than 30,000. So you need to be sure when your RMSE is less than 30,000, so that you not just waste your submission and then it will mark you wrong. So yeah, I'm saying squared is equals to false in order to calculate root mean squared error. If I did not put this part, it's only going to calculate the MSC, that's the mean squared error. But if I say squared is equals to false, so it will calculate the square roots, that's the root mean squared error. And then now for my test data set, that transform data that I defined earlier to transform my data. So I'm going to use it to transform my test sets. So and after that, my they said that my final answer should be called a variable based underscore results, and it should contain just two columns, the customer ID and the spend. So I will start with my base results, the test set I was given. So I'm starting with it with as a data frame that only contains one column, that's customer ID. For example, if this test underscore dummies is the variable I have here. So if I say this test underscore dummies and then I select the customer ID column using just single square bracket, I'll be generating a series. But if I use double brackets, double square brackets, I'll be generating a data frame. So that's the reason why I'm using double brackets here, to generate it as a data frame. So and then for the spend, the second column that is needed is just the prediction on my test underscore dummies dataset. This test dataset that I have with all categorical by columns, I've gotten the dummies for them. So that's what I will use as my second column. And then so I'm having a warning. So I have just two columns, customer ID and the spend, and these are like the first few values in that data frame. This is my base results here, and then my customer ID column, my spend column. So and if you check for every tax, the final variable that they ask me to like create, I usually either print it out if it is not much, or print part of it out to ensure that everything that they ask, that I followed it. So the next one is tax 4. It's similar to this first one, but now we just want to build a model that is more fine-tuned, like that we need to like fine-tune more. So yeah, I'm using K food. I'm using 5 splits of K food. And then my parameter grid are the parameters that I want to change for this model. For example, alpha mp.arrange from 0.1 to 1. So I want to generate 10 values from 0.1 to 1. That's the mp.arrange 0.1 to 1. Oh, sorry. Why is this showing? Hey, have you written nonsense? Hey, sorry. Let me check something. mp.arrange. So we have start, stop. Oh, I've done nonsense, but it still works. Yeah. I've done nonsense. So actually, stop should be here. This should be 10, and then this should be 1. So I'm going to generate 10 values. But the way I wrote it, I used 1 here, and then I used 10 here. So I'm only generating 1 value. So by default, I'm actually not checking anything here. I'm just using 0.0001. Okay. So and then my solver, I want to use different type of solvers. So I'll use the SAG, LSQR, SVD, and LBFGS. These are the different type of solvers I need to use. So these are like hyperparameters for this ridge model. And I'm using RandomizedSearchCV. RandomizedSearchCV is that for every item I have here, I'm going to connect it with every item I have here. For example, if I have 10 values here and I have 4 values here, so I'm going to build a total of 40 models normally. Like for each one here, I'm going to test it with everything here. Each one here, I'm going to combine it with everything here. Like when the alpha is 0.001 and the model is SAG, when the alpha is 0.001 and the model is this, until I've exhausted or every other combinations that I have, and then I'll now choose the model that gives the best results. But in this case, the randomized search, what it does is that it just combines them randomly and just pick random combinations. So it's not going to waste much time. Like if you are checking like grid search CV, that is going to check all the combinations. So randomized search CV is going to just check random combinations of the hyperparameters. And then yeah, I'm training my model. And then yeah, I'm getting the best estimator for the model and the results. So let me run it. So you can see every time you see warning, the model is being created. Hey, okay, well, we finally got our final answer. So yeah, I'm going to get my prediction and then get the RMSE squared error. And then just like I did for that former model, I'm going to generate compare results data frame. So and that's it here. But let's say for example, this place that I made mistake, let's use the correct one, 10. And it's going to take longer, but let's see first. So it's going to take longer now. So this is my best model here. The best model has changed. The alpha 2 has changed. So this is the best alpha. And then with that, our root mean square, before we have 0.329. Now our root mean squared should be lower. Mean squared error. Wow. It's now higher. Wow, wow, wow. So this is not correct. This is not correct. Sorry, this is not correct. 1.26. You know that what the model is doing is that is getting the combinations by random. So there's no guarantee that it will get the best model in the end. But the reason why I always check the root mean square error is to ensure that it is lower than the threshold they are asking for. Once it's lower than the threshold they are asking for, then we are good to go. So that's it. Sorry, any question, omission, or addition? Hello, any question? Sorry, are there no question? Okay, Mr. John already sent the attendance. And I want to ask, how many people have started on the practical currently? Or let me ask, how many people are currently on the exam? How many people are currently writing the exam? Are currently taking the exam? Ah, what's happening? Why is everybody leaving? Hey. Sorry, I cannot hear you. Oh, So you are the one that once you start is going to save time up, right? Yeah, I think I raised the issue with the team and we haven't gotten any feedback yet. But I think you can also raise the issue with the data camp team directly from your account. So I think that way it will be like better. Like they can like trace it to your account and they can fix it faster that way. I think you should try raising a ticket to the support team on data camp from your account.
Yeah, I've done
I
that.
think that,
I've done that already.
okay. And have they replied yet?
And they've replied me. They said next 2 to 3 days that they will reply. I haven't got anything because I'm reporting since.
Okay, hopefully they resolve it soon. Hopefully they resolve it soon.
So like
So
what right now? What can we like start the other data science track?
yes, you can. Yes. Please don't wait for you to finish the certification before you start the data scientist track. Please start the data scientist track, even if you are still taking the certification. Please.
All right.
And I think with all the like material support resources that we've given, the exam should be like easier now. Abi,
Yeah,
it should
sure.
be easier. Apart from the second exam that we cannot like provide more support for. And like I explained, you can just from your first exam, you can take screenshots to like study for your second exam. And with that, your second exam should just be seamless. Yeah.
Yeah. Yeah.
Okay. So any observation? Yeah.
Good evening, sir.
Please, can you please re-explain that tax too? It's kind of, I don't know.
Which part?
The tax too. Where we have
The
to clean data. Yes.
where I'm asked to clean data. Sorry, I did not really get you. Okay, tax 2. Yes, yeah. Okay, tax 2. Yeah, I've got it. So tax, it should be tax 1 here, where we are asked to clean the data. So here, they gave us each of the column and the criteria that each column has. Then we now start cleaning by checking each of the columns first. So here, we are using the loyalty.csv. If we check here, you see that we have 1,246 entries in the data set. And here, from this info, only joining month has missing value. But that's not, we cannot totally say that only joining month is the only column that has missing values, because there will be some missing values in some places that expected. For example, when missing value is inputted as dash, Python will not see it as missing, but in the real sense, it is missing. So we now have to check the columns one after the other. So we are starting from customer ID. Sorry, that customer ID is not here. The customer ID column, they tell us that it is unique identifier for the customer. Unique identifier means there are no duplicate values in the column and there are no missing values in that customer ID. So we cannot use the customer ID column. So the next thing is the spend. The spend of the customer. How much the customer spends. So that's what I'm starting with here. So let's first check the unique values for the spend. So DF is not defined. I need to import, and then let's check DF. So these are the unique values. If you look through it, do you see any value that doesn't look okay? So if you look here, but the data type is float 64 and there are no missing values. But the cleaning format they ask us here is that it can be any positive values to 2 decimal place. Missing values should be replaced with 0. So it can be any positive values to 2 decimal places. So everything here looks to 2 decimal places, but just to be sure, perhaps we are missing something. So that's why this second line here is there. Dot fill NA by 0. We fill any missing values with 0. And then as type float, we convert the data type to a float. So everything here, I put it in np.round, 2. So it's going to like round the final value to 2 decimal places, just to be sure, in case, to ensure that everything they ask for, that we've already implemented it. So yeah, if we run it, so this is what we have. So this is how we are going to like clean our spent this thing. So now we need to keep this somewhere, because the final cleaning has to be done using a function. We want to use a function to do the final cleaning. Although yeah, you are not doing train set and test sets, so you can do it as a whole, but I just prefer to use a function to do the data cleaning, so that I can just use one command to transform from unclean data set to clean data set. So yeah, so that's it. We've gotten how to clean spent, and then we go to first month also. We check the unique values in the first month. So these are the unique values we have there. And they said the first month, the amount spent by the customer, missing values should be replaced with 0. These are the unique values we have there. And then let's try to convert it to a float. Let's try to convert it to a float. It's taking longer than necessary. So here we have a value error. Could not convert string to float. So we have an input here that is just dots. You have an input that is just dots, and Python could not convert it to a float. So we need to treat that dot as a missing value. So that's what I did here. So first, the month, replace the dot with 0. That's still as a string. The column is written in a string. If you check here, first month is object, that's string. So and then as type float, we now convert the data type to a float, and then fill NA with 0, fill missing values with 0, and then comma 2. Comma 2 is for this np.round, to round it to 2 decimal places. Another way you can go about it is at the end here, you can just say dot round into 2, and then it's still the same thing. And then you go to the first one also. So the first thing you need to do is to check for unique values there, and then correlate it with what they asked of you earlier, whether there's any unique values there. So yeah, let's go to the region first. These are the unique values I have in region: Asia, Pacific, Middle East, Europe, Americas. And if you check here in the region, those are the values, the 4 values they asked of. And if you check here also, the region, there's no missing values there. And since they are categorical, we can leave it as object, that's string. But just to be sure, to clear all doubts, that's why I did this fill NA unknown, just to clear all doubts. That's why I did that. So and then loyalty, yes, they said we should fill NA with 0 to 1. Joining modes, fill NA with unknown, and then check the unique values. So yeah, let me check the joining modes. Let me see the unique values. We have none. We have none here. None means missing value. Since it is not in quotation, it means that we can use .fill NA to replace it. So now let's use fill NA to replace that none, and then check unique values again. So you can see that we have, instead of none, we've replaced it with unknown. So we can use fill any to replace that. So here now, this is what we are going to do for this column. So that's just what we did. And then promotion. This dot string dot fill good evening, everyone. Sorry, I did not know like my data went off. I was just explaining since. Sorry, who was the person that asked the question that I was explaining last? Sorry, who was the person that asked the last question about the cleaning part that I was explaining?
Yeah, sorry, I was the one. I have gotten the explanation. You explained the part that I have problems with.
Okay. So thank God. Okay. So sorry. Hope everybody here are currently taking the exam. Have started or currently take or completed the exam.
Sorry, I have a question, please. Is it possible to
Yeah.
continue with the data scientist parts before completing the exam?
Yes, you can. You can. Me, anytime I'm taking exam like this, I usually even take courses. Like I'll break some time after each exam, I'll break, go and take another course, come back, prepare for the next one, take it, break, take another course, come back, take the final one. So I usually break a lot in between my exams. Okay. Okay, so I think this is where we'll be ending our call for today. So the attendance form was shared earlier. It was shared earlier.
So
I don't
it
know.
wasn't shared as a link, it was shared as a note or something like that.
Oh, so you can just check the Discord channel. He has shared it to the Discord channel now. But I'll still be copying it to I will be pasting it in the comment section now. So I just sent it again. Hope is clickable from the comments, from the income messages. Okay, so thank you everyone. We see again next week. So by next week, we are no more talking about certification again. We'll be treating data science courses. Like and the assignments for this coming week will be sent by God's grace this night, and you have till Sunday to complete it. You know, we only have 5 weeks for the data scientist track. We've completed week 1, we are moving on to week 2. So let's be fast. So by God's grace, the 3rd week of December, that's when we'll be finishing the data scientist track. And by then, you should be starting your certification. We are only going to provide you with resources because we are also going to break for the year. So we only provide you with resources so that by January, by the time you are coming back, you should have completed the certification exam and be certified. And after that certification exam, there will not be a final project that will be like sent out by AI Community Africa to have your certificate from AI Community Africa. So, and that will be it. So thank you. So by January like this, just know that we are coming back to come and do the project, AICA project. That's what you are coming back for. The remaining weeks, remaining days in December, use that to finish your certification. Like the second certification, not this one, the second certification. So and once you are done, please one thing again, I heard that you people are not like posting online like LinkedIn on your social platform. Once you get your certification, try to post on your social media platforms and always remember to tag AI Community Africa, please. So thank you. So this will be ending our meeting for today. So we can leave the call now. So thank you.